Hey guys, this video is to help you practice graphing in Vertex form for the test that is tomorrow. What Vertex form means is it takes the parent function of all quadratics, any basic squaring pattern, which just says take a number and square it. Like if you take a number like 0 and square it, we get out 0. If we squared 1, we get out 1. If we square 2 times 2, we get out 4. And if we square 3, we'll get out 9, right? And then if we square 4, we get out 16, which is above the coordinate plane here. Also remember that parabolas, and all parabolas when we graph, we have to take in account that they are symmetrical, right? So we know that where the vertex lives, this 0, 0, we have some axis of symmetry, right? That would be our axis of symmetry. So 0, 0 lives on that. But also, this 1, 1 point reflects over here. Negative 1 squared is still 1. Negative 2 squared is 4, the reflection of 2 squared. Negative 3 squared is 9, right? So using that axis of symmetry helps us get the full curve, right? And that's why when we graph, we need to find the vertex of quadratics when we graph. Okay, so taking this pattern, which also, by the way, to go from the vertex, remember we're going to use the fact that the pattern means we go over 1 and we go up 1. Then we go over 1 and we go up 3. And then we go over 1 and we go up 5. So translating a point around, like the h value in vertex form tells us how far horizontally we go. And remember that if we have x minus h, that means h is positive. And if we have x plus h, that means that we're really subtracting a negative h also. So keep that in mind too. So h tells us how far our graph, this parent function, is going to translate horizontally. Does not affect the pattern between the numbers, between the points, because all the points are going to transform the same way. They're all going to move horizontally. Also vertically, all the points are going to move up and down together. So the pattern doesn't change either when we translate. So the only thing that's going to change the pattern is our stretch factor, or flipping it. So if a is negative, remember all these positive outputs that we get are now negative outputs. So instead of getting out a positive one, we get out negative one, for instance. Okay, so if a is negative, it flips, and then a is our stretching value. So whatever a happens to be, let's say a was 2. Then all that does is it is going to double our moves that we would do. It stretches our pattern by a factor of 2. Or if a was a half, we would take a half of our odd number jumps that we would do. So a is the only thing that affects the pattern here. So keeping that in mind, let's graph a couple. So here's one here. Notice the a is negative, so this graph should open down. Okay, so now we have x plus 2. In our general vertex form, we have x minus h. So to make x plus 2 look like x minus h, we could think of adding 2 is the same as subtracting a negative 2. That's the same thing as x plus 2, but now we have x minus our h value, so h is going to be negative 2, and that's going to be the x coordinate of our vertex, because we went from 0, 0 on the parent function. Now we're translating 2 units to the left, so the vertex goes to negative 2. And then the plus 4 is our k. It tells us the whole graph's going to move up 4. So our vertex is always going to be at our hk relationship. So the graph went 2 to the left and up 4, so the vertex ends up here at negative 2, 4. Okay? So then all we have to do is take a look at our a. It's a negative 1, so the graph got flipped, but it didn't get stretched. So we still can do our over 1, down 1. So for instance, if we put in a negative 3 into our quadratic here, we would expect to get out a positive 3. And let's just check it. So if we put in a negative 3 plus 2 becomes negative 1. Negative 1 squared is a positive 1. The negative says take the opposite of that positive 1, so now we have negative 1. And negative 1 plus 4 is 3. So our movement is right. And now from here we go over 1 and down 3. So it looks like negative 4 is actually a 0 of this graph. Over 1, down 3, 0, 0 is also a solution on this graph as well. So here's some points here. We can go down over 1 and now go down 5. 1, 2, 3, 4, 5, just to make our graph look better. Over 1, down 5. So now our quadratic, and I'm using my mouse here. I hope this looks okay. Looks like this. So there's our quadratic graph of this in vector form. Let's try one more. So here, if you look at our h, we have x minus 3, so that means our h is a positive 3. That'll be the x-coordinate of our vertex. The k value is negative 2, so all the points move down 2. So our vertex is just going to end up at our h of 3 and our k of negative 2. So 3, negative 2. So all we have to go is over 3, down 2. That's where our vertex translated to. Now our stretch factor is positive. We have a half, so it's going to open up. But instead of going our odd values, we're going to go half of those odd value jumps. So if I go over 1, instead of going up 1, I'm going to just go up a half. And then instead of going over 1 and going up 3, now I'm going to go over up half of 3, or 1.5. So here's a half plus 1 more. I think 5 is a 0 from here. Over 1, up a half. Over 1, up 1.5. We can go over 1, up, instead of going up 5, we'd have to go up 2.5, half of 5, right? We can still go over 1 from here and go up half of 7, which would be 3.5. So I can go up a half plus 3 more. So these points right here all fit on this quadratic curve. Okay? So that's how we graph in vertex form.